Hello, Integrated Math 1. Welcome to the second half of this lesson, Module 1, I'm trying it again, Module 2, Topic 1, Lesson number 2, and we're doing the second half of it today. So we left off on our last lesson where we were talking about Maryland selling t-shirts at the festival, and they were $15 each, right? But now we know that, I don't know if you know this, but when you go to set up booths and set up things at festivals, other costs start creeping in. So for the next festival, Maryland's mom suggests that she still sells each t-shirt for $15, but she should give away 3 t-shirts in a raffle. Oftentimes just a way to drum up business, right? A way to get people to come by your booth and maybe buy more stuff is by having a little raffle. So this new relationship, which we're going to call G of T, is shown on our lovely graph over here. So here's the original E of T, 15 equals 15T, right? We had that from last time where we left off. But now look what's happened to our graph G of T now that we're giving away 3 t-shirts in a raffle. It's changed a little bit, hasn't it? So I would like you to just take a moment to compare these two graphs. What kind of stuff do you notice? So for part A, tell me, how do the graphs show the selling price? How do the graphs show the selling price per t-shirt remains the same? Go ahead and hit pause, jot down your thoughts on that, and hit play to go on to the next question. So we said last time that we were selling them for $15 per t-shirt, and that was our slope here on E of T. Now, as you can see, I've got the same slope or the same average rate of change going on here with G of T. So we're still selling them for $15 per t-shirt, and that's obvious by the fact that both graphs have the same slope or the same average rate of change. Determine and interpret the meaning of y equals g of 0 in terms of the graph and the scenario, and label the point of the graph. So if I'm doing g of 0, remember that means we're plugging in a 0. Where is that on my graph, and what does that mean in terms of our scenario? Go ahead and hit pause to take care of that, and then hit play when you're ready to check your work. So first of all, g of 0, that just means I'm going to plug in a 0 for x. Guys, g of 0 is my y-intercept, right? Y equals g of 0 is represented by the point 0, negative 45. There it is, right there on my graph. It's my y-intercept. So it's this lovely little point right here. So it means that if no t-shirts are sold, Maryland's potential earnings is negative $45. She's out $45 if she doesn't sell any t-shirts because she's giving away 3 for free at the raffle. That's what that means. That's very sad, Maryland. It's very sad. I hope you sell some t-shirts. Part C, determine and interpret the meaning of G of T equals 0 in terms of our graph and our scenario. And again, label the point on the graph. So where would G of T equal 0? Go ahead and hit pause, jot down your thoughts, hit play when you're ready to check. So G of T equals 0. When would this function equal 0? Right here, right there, right? That's where it would equal 0. G of T equals 0 is represented by the point 30 on the graph, right there. There it is. So it means that once Marilyn sells or gives away her 3 t-shirts, her earnings are 0. And it's that point right there. Boom. See, I made a pretty little point. Isn't it pretty? So here's the deal. Michelle and Myra each wrote an equation to describe the effect of giving away 3 t-shirts. Marilyn is giving away 3 t-shirts, so she has 3 fewer shirts to sell. So that means that Michelle thought of it in that way and wrote it as G of T equals 15 times the difference of T and 3. But Myra thought of it as, well, the cost of giving away 3 shirts is $45. So she thought of it as 15T minus 45. So they each wrote an equation and they just had different ways of looking at it. So I would like you to take a moment using what you know from last time, earlier in the week. I would like you to take a moment to look at these equations and do a little bit of math and verify that the two equation representations are equivalent. Verify that they actually are the same equation. Just do a little math there. Go ahead and hit pause to do that and then hit play when you're ready to keep discussing. So I actually started off with Michelle's equation. Her whole idea of if she's giving away 3 t-shirts, she has 3 fewer shirts that she can sell. So I took my 15 times t minus 3, and then I used, I used this guy and I used the distributive property, and I was like, distribute, hang on, I want my pen. And I was like, distribute. So 15 times t over here, and then 15 times a negative 3. Or minus 15 times 3. I didn't write that very well, did I? So that means if I do negative 15 times a negative 3, that gives me negative 45. And sure enough, it now matches Myra's equation exactly. Yeah, so look at that. So I just used a little bit of distributive property on Michelle's equation, and I got Myra's equation. That's very convenient, very nice. So now I have another question. You remember last time where we figured out how many t-shirts Marilyn would need to sell to earn $100? But now we have a new situation where she's giving away 3 t-shirts here. Use this graph and an equation. Remember we had 2 methods of solving this. I would like you to figure out how many t-shirts does Marilyn need to sell to earn $100? Go ahead, hit pause to work this out. Hit play when you're ready to check your work. So I went ahead and I used both methods. I started with the equation because I like the equation. It's a thing. So G of t equals 15t minus 45. So I said, okay, well, that has to equal 100, right? She wants to earn $100, and G of t is our earnings. So then I added 45 and I got 145. And then I divided by 15 and I got 9.67 going forever and ever. Now we know from before that we can't sell part of a t-shirt. You either sell the t-shirt or you don't sell the t-shirt. So that means I got to round up if I want to make at least $100. So Marilyn needs 10 t-shirts to earn $100. But remember, she's giving away 3 of them. So that means that she's giving away 3. She's actually going to need to sell 7 t-shirts to earn her $100. You also could have gotten this answer, by the way, on your graph. Remember, we had a way of doing that on a graph where I'm like, oh, look, here's 100. So I drew a line like through 100, and where I did the whole I'll draw, do the graph of this line, do the graph of that line, and look at where they intersect. And they intersect right there, which is the point 9.67. 100. So we actually do get the same answer, whether you use the graphs or whether you use the equation. Remember, we have 2 ways of doing that. So let's fill in this lovely table here. So considering the expressions in the first 2 rows that define the quantities of the function and the parts of each equation written by Michelle and Myra. So look at those 2 expressions that Michelle and Myra used to write their functions, to write their equations. And I'd like you to use that to help you complete this table. It will be easiest if you start by determining the unit of measure before you start trying to tell me what the meaning is. When they say contextual meaning, that just means the meaning within the problem. When they say mathematical meaning, it's just what's the math behind that. So go ahead and fill in this whole table. Again, it's probably easiest if you start with the units and then work your way across. Hit pause to fill in your table. Hit play when you're ready to check. So this was easy with the units to start off with because we know that T is the number of t-shirts, right? It's how many t-shirts we're selling. So within the meaning of this, that means, contextual meaning with the meaning within the scenario, number of t-shirts sold. There we go. Mathematically speaking, we would consider that our input, right? We input the number of t-shirts we sell, and the output we get is G of T, which is dollars. Got some cash money. Yeah. So we've got our dollars here. And of course, the contextual meaning is potential earnings for selling t-shirts, how much money she gets for selling her t-shirts. And that is, of course, our output. We input t-shirts, we output money. It's a good business model. If we start looking at Michelle's equation, she had 15 times t minus 3, right? So 15 is our slope, isn't it? That's our dollars per t-shirt. And within the meaning of it, it means that's the selling price of our t-shirt, right? That's how much she's selling each t-shirt for. Mathematically, that is our slope or our average rate of change. Talking about this t minus 3, that gets a little sneakier, but it's not that bad. I mean, we know it's in t-shirts. We know that's the units. T is t-shirts. But why the minus 3? Well, because it's the number of t-shirts to be sold without counting the 3 freebies. We've got those 3 freebie shirts thrown in there. So that's why the minus 3 is in there. And of course, this is the input minus a constant. So we know that t is our input, that t-shirts are our input. We're just throwing a constant onto that thing because we're giving away a couple of shirts. That's how it goes. Looking at Myra's version of the equation, 15t and a negative 45. So that 15t is in dollars, actually, believe it or not. Because remember that 15 is in dollars per t-shirt and t is in t-shirts. So the t-shirts cancel out and you just end up with dollars. Contextually speaking, this is the earnings for t-shirts being sold. This is how much money she gets as she sells t-shirts. And so it's actually a rate or a slope times the input of all the weird things. I put rate for average rate of change, but again, you could have used the word slope there. That would have been fine. The minus 45 is also in dollars. That's the dollars that we're not earning because 3 t-shirts are given away for free. Yeah, so that's why it's a negative 45 because we did not earn the $45. We gave away t-shirts. And of course, that is our Y-intercept. I hope you caught that on the graph. That negative 45 is actually our Y-intercept, mathematically speaking, on our graph. So that's kind of snazzy and cool to know about. Let's talk a little bit more about these 2 equations that Michelle and Myra each wrote. The linear functions that Michelle and Myra each wrote are equivalent. They're the same. However, they are written in different forms. So the one that Michelle wrote, the linear function g of t equals 15 times t minus 3, this is written in what we call factored form because I have something times something, and we call those factors, right? The things that we multiply together are called factors. So that's why it's called factored form, because these 2 guys are being multiplied together. Hey. And of course, Myra's version of it, you probably already recognize g of t equals 15t minus 45. This is written in what we call general form, right? It's the general form of a function. It's totally the general form of a function, right? Because we know it's f of x equals ax plus b. And so you can see my a is 15, my b is a negative 45, all that good stuff is going on. Yay. Just so you know, a linear function can also be referred to as a polynomial function. And as you go through Integrated Math 2, Integrated Math 3, as you go through these other math classes in the years to come, you will talk a lot more about polynomials, especially if you take Integrated Math 3. You're going to spend a lot of time on polynomials. So this can be referred to as a polynomial function. A polynomial is a mathematical expression involving the sum of powers in one or more variables multiplied by coefficients. That sounded like a mouthful. Either way it works. But it just means that you're adding a bunch of terms together that have different powers. And they may or may not have different variables. It may be only one variable, maybe only x's, but maybe we'll have x's and y's. I mean, you can start throwing crazy things in there. And often they're multiplied by coefficients. Like it just has like, instead of just t, it has like a 15t or negative 22t, that kind of stuff. This is actually really easy. The degree of a polynomial is the greatest variable exponent in the expression. So the biggest power you see attached to a variable is going to be your degree of your polynomial. And that leading coefficient, the leading coefficient of a polynomial is just the numeric coefficient of the term with the greatest power. So if you're like, so whenever you find that degree, right, the greatest power that's hanging out there, that's going to tell you your degree. The number out in front will also tell you the leading coefficient. So it gives you a lot of information. So this is called a polynomial. And it just comes from the word poly, meaning many, and nomial, meaning terms. So it literally means many terms, because we just have a whole bunch of terms we're adding together. So just to give you an idea of what I'm talking about instead of just a bunch of words, if you have a constant function, notice there's no variable here. We say it has a degree of 0. A linear function, you don't see a power here, but technically it has a power of 1, doesn't it? X to the 1 power. Now we don't usually write x to the 1 power, we just write it as x. But those are linear functions when it has a power of 1, and so it has a degree of 1. You know how quadratics work. You see that x squared, and you're like, that bad boy is a quadratic. And because it has an exponent of 2, it has a degree of 2. This goes forever and ever, though. Here I see an x cubed. That's a cubic. So x to the 3rd power is a cubic. And that means because it has an exponent of 3, I have a degree of 3. One of the cool things about these degrees is that it actually tells you the maximum number of times a graph can cross the x-axis. So for example, a constant function never crosses your x-axis. Never. A linear function only hits your x-axis once. A quadratic can hit it as many as 2 times. It can be less than that, but a quadratic can hit it as many as 2 times, because remember quadratics, they do the little U shape, the little bend, right? So it could hit your x-axis twice. And cubics could hit as many 3 times. So that's just some fun little information for you there. But it's pretty easy to find the degree of a polynomial. You just look for the biggest power on your exponent, or pardon me, on your variable, the biggest exponent on your variable, and that's your degree. No big deal. Now, the structure of each linear function, remember we said we had factored form and we had the general form. They each tell you important information about your graph. So, for example, let's consider the general form of a linear function. You know this, f of x equals ax plus b. You know this, where a and b are just some numbers that we shoved in there. I do have to point out that a cannot equal 0. So in this form, my a value is actually my leading coefficient. You know it is the slope, and it is the slope, but it is also your leading coefficient. But it does describe your slope, right? It gives you the steepness. If it's positive, you know your function's increasing. If it's negative, you know your function's decreasing. So it does actually even tell you the direction that your line is going in. Also good stuff to know. And the b value, you know what the b value is. It's your y-intercept, right? Y equals mx plus b. So you know that b value describes your y-intercept. And you know this all from slope-intercept form, right? Y equals mx plus b. You know slope-intercept form. M is your slope, but it's also your leading coefficient. It's also your a value. It's also telling you the steepness of your line. And of course, b represents the y-intercept. You know this. Notice that the general form has the same structure as your slope-intercept form. You've probably already noticed that. The general form is just showing a linear equation, which is a polynomial of degree 1. That's it. So like I said, as you progress more through high school math, through integrated math 1, integrated math 2, pardon me, you're in math 1, integrated math 2 and integrated math 3, you'll learn more about polynomials and degrees and all the cool stuff those things tell you. Yay. I'm going to point out that it really doesn't matter, by the way, what the variable is. We typically use X, but you'll notice with Maryland's situation, we've been using T's. And instead of Y's, we've been using F's and E's and G's. Really doesn't matter what the variable is. Just be careful that you keep things consistent. All right, always good to know. So consider the general form of our function g of t. The general form, if you recall, was Myra's version of the equation. So if you recall, the general form of g of t was Myra's version of it, which looked like this. 15t minus 45, right? That was the general form of our equation. And using this, I just want you to give me a few things. I want you to label A on the graph, and I also want you to label B on the graph. Can you manage that? I think you can. Go ahead and hit pause and do A and B here on number 5, and then hit play when you're ready to check your work. So I know that A is the slope of my graph, right? I know that this 15, this is my A value, this is the slope of my graph. And so I know that's over 1 and up, ooh, sorry, I hit the wrong button, and up A. There you go. I put it on my graph. Over 1, up A. Yay. There's my A value on my graph. For B, we know that B is the Y-intercept of your graph. So I'm like, here's my Y-axis. Oh, it smacks into it right there. There's my B. And in this case, of course, that's where the negative 45 comes in. That's 0, negative 45. Yay. So we're pretty comfortable with the general form of the linear equation because you've been dealing with slope-intercept form for so long. It gives you the slope, gives you the y-intercept. Great. A is your slope, B is your y-intercept. Wonderful. But let's talk now about the factored form. The factored form of a linear equation looks like this. F of x equals A times x minus c. And again, A and C, they are real numbers. A cannot equal 0, just like before. When a polynomial is in factored form, the value of x that makes this factor here, x minus c, the value of x that makes this equal to 0 is the x-intercept, right? The general form gave you the y-intercept, but check this out. Your factored form, if you set that equal to 0, it will give you your x-intercept. This is also called, this value that we find is also called the 0 of the function. So a 0 of a function is a real number that makes the value of the entire function equal 0, or f of x equals 0. So whenever they're asking you for the 0 of a function, we're actually asking you for the x-intercept. Yeah, so another term for x-intercept is the 0 of the function. It's where the function equals 0. That's an x-intercept. That's what it does. So don't freak out when if you're being asked to find the 0 of the function. You now know it's just the x-intercept. It's where your function equals 0. So an easy way to find it is you can take this whole x minus c, this little guy in your parentheses, and just set it equal to 0 and solve it. That will determine the point on the graph where it crosses the x-axis. It's such a great trick, and it's not very hard to do, which is the best part. So here's what I would like you to do. Consider the factored form of our function. If you recall, that was Michelle's form of the function, if I recall correctly. So we had 15 times x minus, that wasn't an x. It's supposed to be a t. Hang on, I will fix it. Thank goodness for erasers. T minus 3, there we go. So here's our factored form of the equation. So what's your A and where is it on your graph? And part B, what's the 0 of the function and where is that on your graph? Go ahead and hit pause to answer A and B here on number 6, and then hit play when you're ready to check your work. So first of all, as always, A is the slope because A is always the slope. So the A value is the slope of the graph. So again, I would go over 1 and I would go up A units. Yay. And in this case, of course, we know our slope is 15. Our A value is 15. For part B, it says to label C on the graph. All right. So you remember that the C value is the x-intercept of the graph. So it's actually super easy to find on the graph. You can see, boom, there it is. There's my x-intercept. It's at 3, 0. Yeah. Not too hard, not too bad, no big deal. We know that C gives us our x-intercept. That's nice to know. So what is the 0 of g of t? Go ahead and hit pause. Jot down your thoughts on that and explain how you know that. Go ahead and hit pause to write that down. Hit play when you're ready to check. Now, you already know that the 0 of the function is the x-intercept, and we've already found the x-intercept, but I just want to go over real quick here with you. So you've got g of t equals 15 times t minus 3. Do you remember how we said you could use this guy to find the 0 of the function? That you could be like, fine, I'm going to take t minus 3 and set it equal to 0. And I'm going to add 3 to both sides. And I'm going to be like, check it out, t equals 3. Yeah, so it turns out the 0 of g of t is 3. Because if I plugged it in, it would turn everything into 0. And of course, you also know that's the x-intercept on your graph. So the 0 of g of t is 3 because it is the value of t that makes this whole thing equal 0. If I were to plug a 3 in there, 3 minus 3 is 0, it would die. And then 15 minus 0 is 0, and it would die. And so it's the value that if I plugged it in, turns it all to 0. And again, it matches what we know before because we know that's where the x-intercept is. All right, so things are about to get a little more complicated. So here's the deal. The next festival that Marilyn is attending charges a $35 fee to rent a booth. She's still selling her mom's t-shirts for $15 each. And she's still giving away 3 t-shirts in a raffle. But now she also has to pay a $35 fee just to set up her booth. So this graph shows the new relationship. So here's g of t that we were just playing with, but now here is f of t, taking into account the fact that she's got to spend another $35 just to set her booth up. And you can see things have happened to my graph. So once again, I would like you to consider the relationship between the graphs of g of t and f of t. How do the graphs show that the selling price per t-shirt remains the same? Hit pause, you know the answer to this, write it down, and hit play when you're ready to check your work. So how do I know that these graphs are telling me that I'm still selling t-shirts for $15 a pop? Because they have the same slope or average rate of change. My average rate of change is not changed. That was deep. My average rate of change is the same. I have the same slope. I'm still charging $15 per t-shirt. That hasn't changed at all. See, same slope. Ooh. So how did the new booth fee then? That $35, how did it change our graph then? Go ahead and hit pause, jot down your thoughts on what happened to your graph, and then hit play when you're ready to check your work. So earlier, when we were giving away 3 t-shirts, we noticed that our y-intercept was negative 45. But check it out. Now that we have to pay $35 fee, our y-intercept is all the way down at negative 80. So my y-intercept shifted down from negative 45 to negative 80. Oh my goodness. So how many t-shirts will Marilyn need to sell before she will have any money to return to her mom? Go ahead and hit pause, take a look at these graphs, jot down your thoughts on that, and then hit play when you're ready to check your work. So I noticed that my x-intercept is 0. 0 is the break even, right? Like I'm in debt before that, but I'll make money after that. So here I can see my x-intercept happens just a little bit past 5. But remember, I can't sell part of a t-shirt. I either sell 5 t-shirts or I sell 6 t-shirts. 5 t-shirts, I would still not be making money. You can see I'm still just a little below. But if I sell 6 t-shirts, that gets me above my x-axis. So I'm going to say that Marilyn's going to need to sell at least 6 t-shirts before she's got any money to return to her mom. Yeah, because you're looking at that graph, Y values, right? If it's below the x-axis, we're not making money. If it's above the x-axis, we're making money. So that means we got to get to 6 t-shirts. 5 t-shirts, I'm still just a little in debt. 6 t-shirts is when I finally start making some cash. Always good. So how many t-shirts will Marilyn need to sell to earn $100? Go ahead and hit pause to see if you can figure this out, and then hit play when you're ready to check your work. So I haven't yet written out a function for f of t. If I had, I would just set it equal to 100 and solve it, but I haven't yet. So I'm going to use the graph to help me out here. So here we go, $100. So I'm going to draw a line right through that $100 and see where it intersects f of t, and it looks like it hits right there. So when f of t equals $100, it looks like I have to sell, 12 t-shirts. Yeah. But also keep in mind, because she gave away 3 t-shirts and paid $35 fee to rent the booth, she's going to need to sell another 9 just to make $100. This is getting pricey, Marilyn. This is getting pricey. Is it worth it anymore? I don't know. Hey, speaking of that function that we haven't written yet, write the function. But notice what the question is asking you for. Can you write the function f of t in terms of g of t? Like, what did you do to g of t to get f of t? Give that some thought and write down your thoughts on that, and then hit play when you're ready to check your work. So don't overthink it too much, but looking at those graphs, remember how we said we shifted down in order to get from f of t to g, in order to get from g of t to f of t? So basically, I had to take g of t, and because I have to pay $35 for the booth, I have to take g of t and subtract $35 to get f of t. Yeah, that's what happened. So I've written f of t in terms of g of t, that I had to take g of t and subtract out that $35 for the booth. But this looks weird, right? Like, we don't usually write functions like this. It's kind of weird, isn't it? So here's what I'm going to suggest, is that you take this lovely guy right here, and can you rewrite f of t in general form? You know what g of t is. Take this guy. Take g of t. You know what g of t is. Plug it in and then clean it up so that you can get it in the general form. And then tell me about your a values and your b values. Go ahead and hit pause, jot it down, or maybe you can even use the graphs to write it down, and then hit play when you're ready to check your work. So you could have written the general form from the graph. That is true. I chose to use my little guy from earlier, my g of t. We know what g of t is. G of t is 15t minus 45. We know that from before. But now I have this extra bonus minus 35 on the end. So I'm going to combine my like terms. A negative 45 and a negative 35 gives me a negative 80. So it looks like the general form of f of t is 15t minus 80. Which again, you probably could have got from the graph, because you know that the a value is your slope, which we already knew was $15 per shirt, and the b value is your y-intercept, and happened at 0, negative 80, so that makes sense that that's where we ended up. Fair enough. It's also why you could have used the graph to find the function as well. One more thing, now that we have this lovely guy in general form, as he should be, can you rewrite f of t in factored form? You may have to use a fraction to represent the c value. Go ahead and hit pause to work that out, and then hit play when you're ready to check your work. All right, guys, How'd you do? Ooh, sorry, I've got some weird stuff showing up on my screen. I'm gonna do this. We'll see if that makes it better. That doesn't make it better. Hang on, we're gonna make it better. We are, I promise. I'm gonna make it better because I've got skills like that. Because I'm magical and amazing. There, that's better. All right, so we're gonna rewrite our lovely little guy here in factored form. This front part guy is easy because I can just rewrite that as 15 times t, no big deal. It's rewriting this guy in the back as 15 times something that made it a little harder. So I had to use my calculator to help me out a little bit, and I did 80 divided by 15. But I got a decimal, and then I had to turn it into a fraction because it said to use a fraction to represent the C value. So I did that, and I got 16/3. When I did 80 divided by 15, I got like 5.3333333 going forever, and I realized that that was 5 1/3, also known as 16/3. So I had to do a little bit of work there to get that fraction on, but I did get it. I got there. We got there. It's fine. So I can rewrite this as 15 times t, and I can rewrite negative 80 as negative 15 times 16/3, which allows me to factor out the 15. That's why we're doing this. So it takes the 15 out, and I end up with t minus 16/3. And now it's easy to describe my a value and my c values. I know that my a value is 15, and it's my slope. I know that my c value is 16/3, and it's my x-intercept. Yeah. So that one was a little messier because it certainly did not factor nicely, but we got there. It's fine. We survived. No big deal. This means now we're ready to complete our graphic organizer. We have skipped a couple pages. We're over on page M2-37. We're not doing all of the talk, but just real quick, let's just remind ourselves, right? F of x, here I have f of x. This is fx. F of x equals 2x minus 8. Can you write it for me in general form and in factored form? That's what I want. And if you're feeling like going the extra mile, and then I want you to graph it. F of x equals 2x minus 8. By the way, this graphic organizer is on page M2-38. So if you're not sure where we wandered off to. So give me the general form, give me the factored form, give me, if you're ready for it, give me the graph of it as well. And if you're feeling really feisty, go ahead and fill in the table. It could be fun. Go ahead and pause to work those out, and then hit play when you're ready to check your work. So general form is easy because that's the one they gave me. It's the general form. F of x equals 2x minus 8. A is the slope, negative 8 is the y-intercept. That's our b value. And I'm going to put all of that right here in there. I just put it out here because it would have been too small for you to see over there. But all of this should be written in this little chunk of your box on your graphic organizer. Part B wants the factored form. Fine. I knew I could factor out a 2. I can rewrite as 2x as 2 times x, and I can rewrite negative 8 as 2 times 4, which makes it a little easier. If I factor out the 2, I get 2 times x minus 4. Yay. Again, I know that a is my slope, which is 2. And I now know that c is 4, and that's my x-intercept. Yay. So I put all of this in this chunk of my graphic organizer because it was big enough to see. So again, I'm not going to show you the graph or the table, but if you're feeling a little extra, you totally could have put those guys over in here. As always, I hope you found this helpful and I hope you found this useful. If you got questions or concerns, please feel free to email me or stop by during office hours and I can help you out then. And I'll see you soon. Bye.